Okay, hi guys. In this video, we're gonna teach you how to analyze a graph. So this is really helpful for your exam because in the exam there will be a lot of questions related to analyzing a graph, whether it's literally analyzing a graph or a more complex form of the questions. You will get used to it when you practice a lot. Like you can know that you have to analyze a graph right away if you see the question. So we're gonna start with the simple one. So if we have a function here, and we're gonna have to find the x-intercept, the y-intercept, the vertical asymptote, the horizontal asymptote, the critical value, which is also the max and the min, and the points of inflection. All of them can be done, and I'm gonna teach you in this video. So first thing, we're gonna start with the x-intercept and the y-intercept since they're the easiest. So to find the x-intercept, you need to factor the original function. So to factor it, I'm sure you guys can factor this. You can plug it into your calculator. If not, then I'm sure you have learned to factor this, and I'm not gonna reteach everything because this video will be really long. So I'm just gonna factor it right away. So it becomes, if you simplify it, you will get this, and then you factor again, you will get this. So if you set this equals to 0, you will get x equals to 0 and x equals to 4. I'm sure you guys understand this step, so I'm just gonna go right away. So the x-intercept will be 0, 0 and 4, 0. And then for the y-intercept, you just need to plug x equals to 0 to the original function and find y. So in this case, f of 0 equals 0 minus 0 plus 0 minus 0, which is equals to 0. So the y-intercept will be 0, 0. The next one is the vertical asymptote and the horizontal asymptote. These two mainly applied for the function that has fraction in it. So I'm just gonna tell you the principle. So to find vertical asymptote, for fraction, the bottom part, which is the denominator, has to equal to 0. I'm just gonna give you examples since here there is no fraction. So in this case, it's none. But I'm gonna give you an example. So for example, I have x plus 3, x minus 3. So here, this x plus 3 over x minus 3. So the vertical asymptote will be x equals 3 because you set this equals to 0. And then for the horizontal asymptote, again, it applied only for fraction. You take the limit x to s approaches to infinity. I'm sure you guys have learned it. I'm sure you guys have learned this thing. X plus 3, x minus 3. By the way, in this case, there is no fraction, so it's none. I'm gonna make example. Here, I'm sure you guys remember that to find the limit as it approaches to infinity, you take the coefficient of the highest power of x. For example, here you have x and x. It's the same power, x to the first power, x to the first power. So in here, the coefficient of the x are both 1. So the limit as it approaches to infinity is 1. So the horizontal asymptote is 1. Y equals 1. If the function is like this, x squared plus 3 over x plus 1, which the upper part is bigger than the lower part, it becomes infinity. So y equals infinity. If, for example, it's 1 over x plus 1, it becomes 0, the limit as it approaches to infinity. I'm sure you guys have learned this, and I'm sure you guys remember. So I'm just gonna move on to the next one. So this is the most important thing, I think, for the AP exam. If you can have a function, and this is the function, and you have to find the critical values, which is also the max and the min. You need to set the first derivative of this equals to 0. So first we're gonna find the first derivative, which is 4x third minus 36x second plus 96x minus 64. And then we're gonna factor this. You can plug it into your calculator, you can factor it by yourself, and we're gonna get x minus 1, x minus 4 to the second power. And then here you set it equals to 0, and you get x equals 1 and x equals 4. After you get the x's, you have to plug it. You have to make table like this. So you plug in the value. So you plug it in 1 here, and you. So this is the table is x value, and then the f of x. The f prime of x. So this is how you find the maximum and the minimum. So this is the critical value. Critical value. After you find the critical value, to find the maximum and the minimum, you need to use this table here. So here you plug it in 1, and then the f prime of x will be 0, because you plug in f1 here, it's 0. And then you plug in 4 here, it's also 0. In this in between, you're gonna plug in the x value less than 1. We're gonna use 0 to make it easy, and you plug it 0 here. And then here, you don't need to have the exact value. You just need to know whether it's positive or negative. So we plug it in. We plug 0 here. 0 minus 1, and then 0 minus 4 square. So here minus 1, minus 4 square. This is negative. This is positive. So it will be negative. And then in this value, we're gonna choose we're just gonna choose between 1 and 4. Just choose 2. So for example, we plug it in 2 minus 1, and then 2 minus 4 square. So this is 1. This is negative 2 square. Because it's square, it will be positive, positive. So here is positive. And then here, for example, we choose 5 because 5 is greater than 4. Just plug it in 5 to here. 5 minus 1, and then 5 minus 4. 5 minus 4 squared. This is gonna be 4, and then 1 squared. Positive, positive. This will be positive. As you guys know, I already explained in the video, in the last video, that if this is negative, this means the original function is decreasing. And then this becomes positive, it becomes increasing, and then this is also increasing, so it keeps increasing. So basically the function will be like this. I'm not sure exactly if the function is like this or not, but this is the sketch of it. Since here it's decreasing until x equals 1, and then it's increasing. This is x equals 4, and then it keeps increasing. So in this function, as you can see from the function, from the graph, the minimum value will be x equals 1 at x equals 1, and there is no maximum relative maximum since it keeps increasing. So